I'm Carl Anthony, managing editor of AutoVision News, and this is AutoSens Insights. We're speaking today with Thomas Sommer, who is the sales manager for Lumentum. And Thomas, thanks for taking some time to get caught up with us today.
Thank you. Thanks, Carl.
Thomas, for our AutoSens TV viewers who may not be familiar, can you tell us a little bit about Lumentum? Tell us about the company.
Oh, absolutely, yeah. I mean, Lumentum has been around for quite a long time. We used to be known as a company called JDSU that then has been spun out. The optical component portion has been spun out about 5 years ago to become Lumentum. Our traditional key markets have been telecommunications, fiber optical components. And from that, we have all the technology of laser diodes and transmitters that we're now using for other applications like 3D sensing, LiDAR applications. The company is headquartered in San Jose, about 5,000 people, $1.7 billion of revenues. We've just announced our latest quarterly numbers. And still the majority is telecom business, but our 3D sensing business is accounting for a bit more than a quarter now and growing. So it's an exciting place to be in now in the 3D sensing LiDAR space.
Now, Thomas, speaking of most recent announcements, you actually have a new announcement here for this interview. So can you go ahead and tell us a little bit about that new announcement and that latest news with Lumentum?
Oh, absolutely, yes. I mean, what we're announcing at AutoSens this year is our latest generation of addressable high-power VCSEL arrays. I mean, for those people that are not familiar with that, what is a VCSEL array? What is multi-junction high-power VCSEL array? A VCSEL array is a set of VCSELs, an array, a bigger area of individual emitters put together. And this has been around for a while and has been used in mobile applications, 3D sensing mobile applications. And we have increased the output power of these VCSELs by adding additional PIN junctions. Instead of having single junctions chip, we now have 5 junctions, which gives us more photons per injected current, higher power, and that is very important if you go to longer reach LiDAR applications. And just to give you an idea how much power we are getting, from really tiny chips, we are getting 100 watts at less than 30 amps of forward current, and very, very high slope efficiency, like more than 3 watts per amps. And if you talk about power density, we're getting something like 800 watts out of a chip that is 1 millimeter in square size. And that's very important for LiDAR. And the other important point is the addressability. I mean, we're not only able to light the whole VCSEL array, but we can actually light individual sections of this VCSEL array. We can even lit individual emitters or one-dimensional stripes, whatever is needed, and we can match that to the receiver side that is used to in a LiDAR receiver. And that's new. It's been discussed for a while, but it's reality and it's available now.
So Thomas, with that in mind, speaking of LiDAR, which is a key topic, especially for ADAS and autonomous applications. But there are key requirements. So one of the things I know we wanted to talk about is what are the key requirements for automotive LiDAR applications? And then furthermore, what challenges are associated with the light sources that are used?
Oh, absolutely, yes. I mean, the requirements for automotive LiDAR are quite clear. They always want to go longer reach, better resolution, better angular resolution, better distance resolution. And at the same time, the whole thing has to be small, has to be integrated neatly in a vehicle, has to be super reliable. And obviously, we need to respect also the eye safety limits. If we go higher power, we still need to make sure that everything is safe. And what that means for the light sources that are used in LiDAR is obviously make it higher power, make them small and compact. Another aspect that I forgot is cost. Obviously, the lowest cost is needed as well. So you need the scale to make those chips. Need the fabrication, need the processes in place, and I mean, one thing we can say is that the complexity of a LiDAR, the beam steering of a LiDAR is now being moved towards the semiconductor, towards the VCSEL chip. And that means we are addressing this with these addressable chips where we can light individual sections of the chip. And yeah, it's a key for automotive LiDAR to have that available. And I think we are in a great position to help them and make sure they meet their requirements and meet their customers' requirements.
So Thomas, this is a good transition into the next question. And talking about a high volume mobile product line for automotive LiDAR applications. So can you explain how Lumentum is leveraging that for your customers?
Absolutely, yes. I mean, you're right. I mean, we are a very high volume manufacturer of VCSEL arrays for mobile applications. We've made more than 600 million pieces by now. And to be clear, the VCSELs for LiDAR, the higher power VCSELs, are really an evolution of those other VCSELs that we've been making already for years. And we can absolutely leverage on the processes that we have in place already, on the manufacturing flows. We use the same 6-inch gallium arsenide wafers to produce them, and use the whole scale and everything that has been established for mobile already. And something that people maybe underestimate is that even for mobile consumer applications, reliability is a key, and those chips are already used in pretty harsh environments. They're outdoor applications, really. And we're already using our knowledge in these environments, in these conditions, also for automotive. Another big advantage that we have really is that the fab that we are using is already IATF 16949 qualified, and that's a key for all automotive applications anyway. So we are really in a great position to use everything that we've used for our mobile VCSEL arrays in automotive as well. So that's a huge advantage.
Thomas, we had a couple of minutes ago, we had talked about reliability, and I want to come back to that because I think it's an important point for our AutoSens TV viewers, and it's the fact that automotive applications are going to need the highest reliability possible. So how is Lumentum addressing that?
Well, it's a very good question and very important indeed. I mean, one thing is Lumentum's culture is a quality culture. As I mentioned earlier, we're coming from the telecommunications field, and that includes, for instance, submarine, fiber optical submarine cables, and failures in a submarine cable are not an option. So the whole company is set up around these requirements. We're living the Kaizen culture, ever improving qualities, and that's the basis of everything. And the fact that we have produced more than 600 million VCSEL chips already for mobile applications with essentially 0 failures shows that we are living up to that standards, and we're obviously transferring all these standards and processes to automotive. I can also say we've already got our first VCSEL chips AEC-Q qualified. It's an in-cabin single junction VCSELs, not that high power than the new generations. So that's great news as well, and shows that these VCSEL structures are strong and robust enough. And we've done first tests on the higher power junction, multi-junction VCSELs as well, and they show very, very strong stability, same reliability. And in fact, we've had a couple of customers that were trying to break those chips because they want to understand what is the failure mode that happens first on those, but they were not able. They were overstressing the chips and trying to figure out what could actually happen to them, that they didn't succeed. So I think we're on a very good path, super confident that we can meet those requirements.
It seems, Thomas, when you talk to engineers in the field, or you read white papers, or read articles, or if you study this part of the industry at all, there doesn't seem to be a general consensus yet on the best approach for LiDAR. So your customers are following different approaches, different applications, different requirements. So how do you, as Lumentum, how do you adjust to this and adopt to these variety of different requests?
Yeah, another very good point. I mean, you're right. The requirements are definitely not settled. There's different ways, even reaching to FMCW versus time of flight. But even just talking about time of flight application now, there are all kind of requirements, different geometries, different optical apertures, different performances. And the good thing is that we at Lumentum, we do have a really big toolbox that we can use, and we can easily adapt to those requirements. As I mentioned, the addressability is one of the things. We can make those VCSEL arrays addressable in whichever geometry you want, stripes or squares or horizontal or vertical stripe, whatever is needed. And we can put all that together. We also have sophisticated simulation tools, and we use those tools to always optimize the performance, make sure we are using the optimum pitch. We can match those VCSEL pitches to the receivers that are being used together with them. And I think that's the way we address that. And our customers have been pretty impressed. When they come with a new sensor, a new receiver, and they ask us to match that with a corresponding VCSEL chip, they can see that we can adapt very, very quickly and really exceed their requirements.
So, Thomas, that sort of then transitions into the next question. So, do you work together with SPAD and other sensor makers? And what I mean by this is aligning your light sources then with the latest sensor technologies and arrangements.
Yeah. Yes, we are, and it is absolutely necessary, right? The receiver and the transmitter, they have to evolve together, and we need to understand each other to make sure that the light sources match what the receiver can do. And we're working with those SPAD vendors, exchanging information. We are building reference designs for our customers that they can use immediately without spending a lot of design efforts. They can check the performance that they get out of those reference designs. They can learn how to calibrate both the complete sensor. And I think it helps us as well, to keep a finger on the pulse of the sensor and the SPAD evolvement, make sure we are anticipating trends that they are seeing, and we match those trends. So absolutely, I think it's a key thing we are doing, and we want to follow even more in the future.
Sure. Now, Thomas, we've talked quite a bit about LiDAR, and understandably so, but in addition to LiDAR applications, do you also address in-cabin driver monitoring systems, and specifically for your VCSEL products? We've talked a lot about your VCSEL products too. Mm-hmm. So do you do any work in-cabin driver monitoring passenger systems, and is there a correlation between that and your VCSEL products?
Yeah, absolutely. Yes, we do. We have actually a whole series of VCSEL arrays for in-cabin, for driver monitoring, occupants monitoring. And usually the users of those systems, they want to have those already packaged, integrated, maybe with a monitor diode, with a driver, a diffuser on top. And that's something we typically don't do. So we work with some partners to create those packaged solutions for in-cabin applications. And I did mention that we have a VCSEL array already AEC-Q qualified. In fact, that was an in-cabin VCSEL, automotive VCSEL, and that has been AEC-Q qualified together with a packaging partner that did that job, and we did it together. And I think there will be soon a PR on this AEC-Q qualification as well. So yes, we are addressing in-cabin as well, as much as outside LiDAR applications.
So what other R&D activities are you working on, whether that's automotive LiDAR applications or something else? Can you tell us any other important R&D activities that you're doing at the moment?
Oh yeah, absolutely. I mean, there's lots of things going on in parallel, but maybe just two things that I want to highlight. One of the evolutions for our VCSEL arrays is bottom emitting VCSELs, and those bottom emitting VCSELs even have lenses integrated on each of the emitters. What that brings is, if you have bottom emitting VCSELs, you can even get better thermal contact, get rid of the heat easier, and having lenses already integrated in those bottom emitting VCSELs makes the beam steering of each individual emitter even more flexible. You can do that very individually and get even more flexibility and better performance out of this. So that's one of the areas we're working on, absolutely. The other one I wanted to mention is, besides time of flight LiDAR systems, we have an advanced technology project for FMCW, frequency modulated continuous wave LiDARs as well, which is slightly different technology. And here we are actually leveraging on our telecommunication products. We're leveraging on our very narrow line width lasers that are used for coherent telecommunication systems. And we adapt those to those FMCW applications. We have a very interesting research program going, showing already first results. And I think these FMCW LiDARs will have a part of the market. They'll probably start in the higher end robotaxi, trucking, autonomous cars market. But due to the advantages of FMCW over time of flight, they'll probably evolve into different markets later on as well. They're obviously a little bit more costly, a little bit more complex. So very likely time of flight and FMCW LiDARs will coexist. But we're following both. We're trying to capture all the bases.
Thomas, I think one thing that I have really gleaned from this interview and talking to you, and I want to go back because I think it's a very important point. We had talked earlier about, there still is not this consensus on what is the best LiDAR approach. And so if I am in the automotive market, I think it's great that I can go to you, I can go to Lumentum, I can come to you with my different requirements, my different processes, I can come to you with my different requests, but you were able to meet those requests uniquely suited to what I need in the automotive market. And I think that's tremendous. And I want to go back and just highlight that one more time for our AutoSens TV viewers.
Thank you. Yeah. That's exactly what we're trying to do, and that's what the market needs, as it is very diversified, and there's different applications, different areas around the car that you want to cover with LiDAR, so you need to be flexible and make sure you can address all of those.
Thomas, in the last few minutes that we have, do you have anything to add? Is there anything that we may have missed?
I think you covered most of it with your questions. I mean, to summarize, the market is there. I mean, now is the time to do your designs, make sure you use what's available in the market, and go ahead with LiDARs. Obviously, in these days, with all the COVID-19 situation, some companies, tier ones, OEMs are a little bit struggling financially, are delaying programs, potentially saving cost here and there. I think it's definitely a tricky time, but I would say now is the time to really invest in LiDAR, make sure that you get a grip on this new technology that helps for driver assistance systems, autonomous cars, and many other applications. So very exciting days.
I agree, Thomas, and LiDAR is an excellent and necessary technology for the future of autonomy. Thomas, I want to thank you for your time. From all of us here at AutoSens, we want to wish you best of luck going forward, and I look forward to catching up with you again at another event, either in person or virtually like this. Thank you for your time today.
Thank you, Carl. I really appreciate it. Thanks for having me here.
We're speaking today with Thomas Sommer, and he is the sales manager for Lumentum. For more great content from AutoSens, check out our hub and our YouTube channel by searching AutoSens.